Welcome to the Explainer. So, right now, the global quantum technology sector is going through a massive structural transition. I mean, we're literally moving away from this purely research-dominated sci-fi concept into a highly commercialized, absolutely booming industrial ecosystem. With venture capital pouring in billions of dollars and governments all over the world just racing to build these quantum hubs, the demand for talent is skyrocketing. So today, we're going to map out exactly how you can navigate this explosive growth and build a truly future-proof career in the quantum industry. Okay, let's dive right into this. Think of this agenda as your personal career fair map. We'll be covering, number 1, the quantum talent shortage. Number 2, busting the PhD myth. Number 3, software and hardware careers. Number 4, security and business roles. Number 5, must-have quantum skills. And finally, number 6, how to get hired.
Section 1, the quantum talent shortage.
Because this industry is leaping from the lab to the marketplace so fast, there's a severe mismatch in available talent. Just look at the sheer scale of the jump here. Right now, there are over 7,000 open quantum positions globally. But then, look at that middle bar. We are staring down an expected talent shortage of 40,000 qualified experts by 2030. And by 2035, the industry is projected to create a staggering 840,000 new jobs. That's huge. This bottleneck is happening mainly because quantum is just so interdisciplinary. Companies can't just hire a pure physicist to build a commercial cloud product, and they can't just drop a standard software dev into writing quantum error correction code without some cross-training. So that talent gap, it is wide open for anyone willing to step up.
Section 2, busting the PhD myth.
Now, what's really interesting here is that we have to address the absolute biggest intimidation factor that stops incredibly smart people from even applying. Do you really need a PhD to work in quantum? Look, it's totally natural. When we hear the word quantum, we almost immediately picture, a brilliant theoretical physicist like an Einstein in a lab coat fiercely writing equations on a massive chalkboard. So it is completely normal to feel a heavy dose of imposter syndrome when you look at job postings in this space. But let me tell you, the reality of the industry today paints a totally different picture. Get this, in the private sector, a whopping 80% of quantum jobs do not require a PhD. Actually, scratch that. It's even more accessible than that. Recent labor market data shows that 55% of open positions require only a bachelor's degree or less. So those days of quantum being this exclusive club for postdoc academic researchers, they're officially over. I absolutely love this quote from Dana Anderson, the CTO over at Inflection. He says, most of what makes quantum work is not quantum. There are very few people who need to know Schrödinger's equation. Honestly, how empowering is that? Quantum devices still heavily rely on conventional software, classical electronics, and standard materials. These companies are desperate for practical problem solvers. They need the person who actually knows how to solder, the person who can write testable, clean Python code, and the person who can untangle a complex supply chain. And this breakdown of academic diversity drives the point home perfectly. Notice that physics makes up just over 26% of the degrees. The rest of the pie? It's computer science at around 9%, math, electrical engineering, and then this massive 58.5% block of other STEM and business disciplines. It brilliantly illustrates that the quantum workforce is deeply interdisciplinary. If you've got a classical engineering or tech background, you literally already have a massive head start. Section 3, software and hardware careers. So what do these jobs actually look like day to day? Let's map out some of the core technical roles, their surprisingly lucrative salaries, and their primary focus areas. A quantum software developer, making well into the six figures, like 110 to 200K plus, is generally writing in Python and using frameworks like Qiskit to build user interfaces, APIs, and control code. Then you have an algorithm developer, making maybe up to 230K. They might focus more on classical optimization or machine learning, basically translating high-level math into quantum circuits. And a quantum hardware engineer, they're the ones dealing with cryogenics, FPGAs, and RF microwave signals to physically control the qubits. Notice how every single one of these maps perfectly to traditional classical disciplines. And this brilliantly illustrates the reality on the ground. Building a quantum sensor or manipulating a qubit relies incredibly heavily on classical technologies. Think of it like building a semiconductor device. If you're an electrical engineer who understands analog circuit design or signal processing, you have the exact skills needed to build the control electronics for a quantum computer.
The hardware is basically a massive foundation of entirely classical systems supporting one tiny little quantum core.
Section 4. Security and business roles.
But hey, maybe you aren't a developer or a hardware engineer. And you know what? That is perfectly fine. One of the biggest subfields right now supporting this whole ecosystem is post-quantum cryptography, or PQC. See, because a mature quantum computer could theoretically break the RSA encryption we use for, well, pretty much everything today, organizations are absolutely racing to upgrade their security. There's this massive, looming threat known as harvest now, decrypt later. That's where bad actors are actively stealing encrypted data today, just sitting on it, waiting for quantum computers to get powerful enough to decrypt it tomorrow. Because of that, cybersecurity pros are urgently needed to help organizations transition over to the new NIST PQC standards. You don't need to know how to build a qubit for this. You just need to know how to manage classical IT and risk assessment for a new quantum era.
And beyond security, the commercialization of all this tech means these companies desperately need operational support. They are actively hiring quantum product managers to design their cloud service roadmaps. They need technical writers and educators who can break down complex, headache-inducing physics into something enterprise clients can actually understand. They need compliance officers to handle tricky dual-use technology regulations, and business development reps who can actually sell these solutions to, say, the finance or pharma industries. Basically, the industry is crying out for translators, professionals who can comfortably bridge the gap between the brilliant physicists in the lab and the business executives sitting in the boardroom.
Section 5. Must-have quantum skills.
Okay, so now that we've mapped the landscape, let's look at the exact toolbox you need to get hired. And I promise you, you probably already have half of what you need. Looking at this comparison, the left side represents your classical foundation, things like Python, Git, C++, RF engineering, data science. These classical STEM skills are the undeniable, rock-solid foundation of a quantum career. The right side? That represents the quantum-specific layer. That's learning how to use an SDK like Qiskit, understanding basic superposition and entanglement, or getting a grasp on the constraints of cryogenics. The beauty here is you don't have to relearn everything. You just have to add that thin quantum layer right on top of what you already know. So the crucial point is that you should really aim to become a T-shaped professional. Framing your career transition this way is huge because it's not about starting from scratch. It's about taking your deep existing expertise in a classical discipline, whether that's software testing, hardware engineering, or even tech sales, and just building a broad horizontal foundational literacy in quantum concepts across the top. And please, never underestimate soft skills in this space. They are literally your secret weapon. Because this technology is evolving so rapidly, the ability to communicate across disciplines is absolute gold. Picture this. You'll be sitting in meetings where a theoretical physicist needs to explain a qubit decoherence problem to a classical software tester and a business product manager. If you can problem solve under uncertainty, adapt to constantly changing hardware specs, and act as that essential translator across those wildly different departments, you will make yourself completely invaluable.
Section 6. How to get hired.
Let's move to this final part and see how this all builds into an actionable game plan. If you're a student or maybe a mid-career switcher, here is a concrete 3-step playbook for breaking into the quantum job market today. Step 1, identify your transferable classical skills. If you already write software, great, you can learn to write it for a quantum SDK. Step 2, upskill via targeted learning. Listen to me, you do not need to go back and get a master's degree for this. Take a professional certificate on edX, or honestly, just spend a few months going through the open source IBM Qiskit textbook and actually running code on real quantum hardware in the cloud. And step 3, leverage your network for lateral moves. Look at companies you might already work near or have connections at, like major cloud providers, defense contractors, or telecom firms, and start looking for lateral moves right into their newly growing quantum divisions.
The quantum industry just isn't a walled garden reserved for a handful of academics anymore. It's a rapidly industrializing sector with incredible salaries, genuinely fascinating challenges, and a massive, massive talent shortage. The door is wide open right now for traditional tech talent, classical engineers, and forward-thinking business leaders. So the only question left to ask yourself is, are you ready to bring your classical skills into the quantum era? Thank you so much for watching this explainer, and I really can't wait to see what you build in our quantum future.